Imagine a future where games outsmart us, where artificial intelligence becomes the ultimate player. That future is closer than you might think. Over the past few decades, we've seen an astronomical surge in the influence and application of artificial intelligence, particularly in the realm of gaming. This fascinating journey began with simpler games like chess, an ancient game of strategy and wits that was taken by storm when AI entered the scene. In the late 20th century, a computer named Deep Blue, powered by AI, challenged world chess champion Garry Kasparov and won. This victory marked a significant milestone in the evolution of AI in gaming, demonstrating the potential for machines to outperform humans in complex strategic games. But the gaming world didn't stop at chess. Next came the ancient Chinese game of Go, considered one of the most complex board games in existence. Once again, AI took center stage. In 2016, Google's AI AlphaGo stunned the world by defeating a world champion Go player. This was an achievement many thought was decades away, further showcasing the rapid development of AI in gaming. But the evolution of AI in gaming doesn't stop at traditional board games. It has transcended into the world of video games, where the challenges are more dynamic and unpredictable. One such game where AI has made notable strides is Pac-Man, the classic arcade game we all know and love. Now you might be thinking, Pac-Man, really? How complex could that be? Well, you'd be surprised. The seemingly simple task of navigating a maze while avoiding ghosts turns out to be a complex problem for AI. So how does an AI learn to navigate the ghost-ridden mazes of Pac-Man? Let's dive in. Pac-Man, a game that seems simple to us humans, poses quite a challenge for our AI friend. To understand why, let's first take a quick stroll down the maze-like lanes of Pac-Man. This game, as many of you might remember, is all about a circular character navigating through a labyrinth, chomping down pellets while dodging ghosts. Sounds pretty straightforward, right? But there's more than meets the eye. For starters, the game isn't just about eating pellets and avoiding ghosts. It's about strategy. Pac-Man needs to gobble up all the pellets in the maze without losing life, a feat that requires careful planning and quick decision-making. It's not just about what's happening now, but also about anticipating what's going to happen next. A single wrong turn could lead to a close encounter with a ghost and end the game. Now, consider the game environment. The maze is complex, filled with twists and turns. And then there are the power pellets. Eating one gives Pac-Man the ability to eat the ghosts, flipping the game dynamics on its head for a few seconds. The AI needs to understand when to go for these power-ups and when to focus on the regular pellets. Moreover, the ghosts are not just aimlessly floating around. Each ghost has its own unique behavior. Some chase after Pac-Man, while others try to ambush him. This means our AI friend needs to understand and adapt to the behavior of each ghost. So you see, what may seem like a straightforward game of eat and avoid is actually a complex task for an AI. It needs to grapple with strategy, adaptability, and a deep understanding of the game environment. The AI's goal is simple: eat as many pellets and avoid the ghosts. But how does it learn to do this? Well, that's where things get even more interesting, and that's a story for another scene. Enter reinforcement learning, the AI's personal tutor. Now, imagine this. You're thrown into an unknown environment with no map, no instructions, just a goal. You try different actions, learn from your mistakes, and gradually you start to figure things out. This is essentially what reinforcement learning is. It's a type of machine learning where an AI agent learns to make decisions by interacting with its environment, by trial and error, and most importantly, by reinforcement. The concept is quite simple, yet profound. The AI agent takes actions in an environment to achieve a goal. It receives feedback in the form of rewards or penalties, which guide the learning process. The goal of the agent is to learn a policy, a strategy, that will maximize the total reward over time. Now let's bring Pac-Man into the picture. In the game, the AI agent's goal is to eat as many pellets as possible while avoiding the ghosts. The AI receives a positive reward for eating a pellet and a negative reward for getting caught by a ghost. It's a game of cat and mouse, or rather ghost and Pac-Man. At first, the AI might randomly move around, occasionally eating a pellet and often running into a ghost. But each time it runs into a ghost, it gets a negative reward, a sort of slap on the wrist, if you will. This tells the AI, hey, that's not a good move, try something else next time. On the flip side, each time it successfully eats a pellet, it gets a positive reward, a sort of pat on the back, encouraging it to repeat the action. Over time, through countless games and countless mistakes, the AI begins to understand the dynamics of the game. It learns to avoid ghosts, chase after pellets, and even strategize its moves. It becomes smarter, more efficient, and incredibly good at the game. Through reinforcement learning, the AI is not just playing the game, it's mastering it. But this is just the tip of the iceberg. The real question is, what does this mean for the future of gaming? As AI masters games like Pac-Man, the gaming landscape is set to change dramatically. Imagine a future where your favorite video game adapts to your style of play, learns from your strategies, and challenges you in ways you never thought possible. This is the future of AI in gaming. As AI continues to evolve, the role it plays in our games will also transform. Today, we see AI used to control non-player characters or NPCs, making them more realistic and challenging. But this is just the tip of the iceberg. With advancements in machine learning and reinforcement learning, the AI of tomorrow will be able to understand and adapt to a player's behavior, creating a truly personalized gaming experience. Imagine playing a game of chess where your AI opponent learns from your every move, or a strategy game where your AI allies develop tactics based on your playstyle. This level of adaptability and sophistication could make for some truly epic gaming experiences. But the influence of AI in gaming doesn't stop at creating more challenging opponents. It also has the potential to revolutionize game development and design. With AI, developers could automate aspects of game creation, such as level design or character animation. This could lead to more diverse and dynamic gaming experiences, as well as more efficient game development processes. Furthermore, AI could be used to create procedural content, that is, game content that is generated on the fly based on certain parameters. This means that no two playthroughs would be the same, as the game world would change and evolve with each session. And let's not forget about the potential for AI to create entirely new forms of gaming. With advancements in virtual and augmented reality, AI could be used to create immersive, interactive experiences that blur the line between the virtual and the real. AI in gaming is more than just a high score in Pac-Man. It's a revolution that's just beginning. The future of gaming is not just about better graphics or more realistic physics. It's about creating deeper, more meaningful experiences, and AI is poised to lead the charge. So, the next time you play Pac-Man, remember, you're not just playing a game, you're participating in a grand experiment in artificial intelligence. Throughout this journey, we've dived deep into the evolution of AI in gaming and how Pac-Man's seemingly simple maze challenge has become a playground for artificial intelligence. We've explored how the AI's teacher, otherwise known as reinforcement learning, has been training AI to navigate the mazes, gobble up pellets, and dodge those pesky ghosts with finesse. We've also taken a peek into the future, a future where AI might just redefine gaming as we know it. But let's take a moment to ponder on the broader implications of AI and reinforcement learning beyond just our gaming screens. Imagine a world where AI can learn and adapt on its own without needing explicit instructions. A world where AI can make decisions based on experiences just like humans. This is the promise of reinforcement learning. It's not just about teaching AI to play games. It's about teaching AI to learn, to adapt, to grow. Consider the applications in robotics, for instance. Robots could learn to navigate unfamiliar environments or perform complex tasks simply by trial and error, just as our AI learned to play Pac-Man. Or in healthcare, where AI could learn to diagnose diseases or recommend treatments based on past patient data. But this isn't a one-way street. As AI learns, so do we. We learn more about the intricacies of intelligence, both artificial and natural. We learn about the potential and the challenges of creating intelligent systems. And we learn about ourselves, about our own ways of learning, adapting, and growing. In the end, it's not just about winning a game of Pac-Man. It's about advancing the field of artificial intelligence, about pushing the boundaries of what's possible, about creating a future where AI and humans can learn and grow together. Who knows, maybe one day the AI might even let you win.